Well, hello. Here we are again. So I figured this works best for having a sum. So today we're going to start section 14.1, chapter 14. We only have 4 sections to do in this chapter, and you guys are done with the book. Isn't that awesome? So it's kind of a continuation of chapter 13. It's about graphing sine, cosine, and tangent functions. It's not too bad, though. It's kind of cool. So I want you to just take a minute just to refresh your memory about finding the sine, cosine, and tangent of pi over 2 and 2 pi. So fill that out real quick. Okay, so this is what you should have gotten for your warm-up. Just as a refresher, pi over 2 is at 90 degrees, and the ordered pair there is 0, 1 from the unit circle. Okay, that's where I got it. I didn't make it up. And then sine is y over r, 1 over 1, or 1 at that point. It's just the y coordinate. Cosine is the x coordinate at that point, and tangent is y divided by x, which is undefined. Same with this. Sine is 0, cosine's 1, tangent 0. Okay, so kind of what we're doing here is we're using the stuff from the unit circle, and we're going to make a graph on a coordinate plane. So if we think about the cosine graph, what we're actually going to be doing is we're going to say, okay, when cosine is 0, actually when we're at 0 degrees, the cosine is 1. When we're at 30 degrees, the cosine is 0.87. 45, the cosine's 0.71. 60, the cosine's 0.5. And at 90 degrees, it's 0. So from 0 degrees to 90, the cosine graph is actually going to go down, and you'll see that. And then here you can see the cosine's getting negative, so it's going to go down into the negatives, and then it's going to start climbing up. So it's kind of a wave, and it's the same with the sine. So don't think too much about that. Just realize what we're doing here. We're taking the information off this unit circle and kind of transferring it to a coordinate plane to see what the sine and cosine and tangent graphs would look like. All right, here's some words you might need to know. You will need to know, actually, the amplitude. It's just like you've probably studied waves in science. The amplitude is how high and how low it goes from the baseline. So the amplitude of a sine or cosine function is how high and how low the graph goes. It will be consistent above and below the baseline, and I'll show you that stuff in a second. A periodic function. A periodic function is a function whose graph has a repeating pattern, like sine, cosine, and tangent functions. They are periodic functions. Cycle is kind of a strange word. The more important word is the period, and you'll see what that is just a moment in a picture. It's kind of the shortest repeating portion of the graph. The horizontal length of each cycle is called the period. And frequency is the reciprocal of the period. So you might want to write this down for later. The frequency is equal to b over 2 pi. This is only for sine and cosine. Don't worry too much about it right now. We'll come back to that later. Okay? It can help you solve for b if you need it. So here's some things you're going to be using for sine and cosine graphs only. They don't apply to the tangent graph. Okay? So amplitude is always going to be the absolute value of a. And you can see here in the general equation for sine of x, the a is out front here. Same for the general equation of cosine of x. The a is out front here. That'll tell you how high that wave goes and how low that wave goes below the baseline. This you won't need to use so much, but it's here. It was in the book, so I put it in there. This here will help you determine the period, which is important in helping you to graph them. And we're going to work with that in a minute. It's just simply always 2 pi divided by b. And you can notice here in the general graph, the b's are here. Okay? And then to help you graph it, if you need to, you can find the intervals for the x-axis by taking the period that you figure out and divide it by 4. And I'll show you that in a minute. So let's just do some graphing. So here's the most basic sine of x function. Y equals the sine of x. Let's first kind of think about what we need to know. Or let's rewrite it in this form here. You notice there's no numbers where a and b are, but actually there is. That means the amplitude is 1 and b is also 1. Okay? I sort of want to go back up here and just kind of make sure you are aware here that the A here is the amplitude in both of those functions. And the B, what that does is it helps you determine the period. Okay? All right. This is a graph that's already, instead of having you draw it, I just kind of pulled an image off Google. And I'm going to kind of show you the different parts on this basic sine of x graph. So the period is always going to be 2 pi divided by b. And we already determined that our b here is 1. So our period is going to be 2 pi divided by 1, which is just 2 pi. And remember up here, the definition of period is the horizontal length of each cycle. So for sine and cosine, you start at 0 and you go over to 2 pi, which is right here. It's like going all the way around the circle. Okay? So that means that from here to here, which is 2 pi, that is my period. That's one cycle of the sine graph. From here to here. Okay? It starts at 0 always, because at 0 degrees the sine is 0. All right? And remember over here I don't know, that's good enough. Let's just talk about that. All right, so there are also 4 intervals in this period right here. So I determined the period to be 2 pi. That's my period. So I'm going to just kind of, to help me graph it, if I didn't already have the graph like I do here, I got to figure out the intervals that might help me graph. So I'm going to do the interval is equal to 2 pi over 4, because it's the period divided by 4. That means each portion of this period is pi over 2. So you can kind of see that you would start here at 0. Here's pi over 2. That's the top of my graph. Here's the center where it crosses the x-axis. Here's the bottom of my graph. And here, and what I mean by intervals is that it's kind of cut into 4 parts. And each of those 4 parts is pi over 2. And again, if you didn't have the graph, it would help you make these points so you can just connect it. And we'll get to that in a little bit, just so you know that's what the interval is. So interval and period. Okay? Now let's sort of think about what you know already with the sine. Okay? What do you know? You know that the sine is the y-coordinate. And you know at 0 degrees, sine is 0, isn't it? You know at 90 degrees, or pi over 2, sine is 1, which is represented right here. At pi over 2, sine is 1. Okay? At pi, sine is 0. I'm not making it up. It's right off of here. At pi, sine is 0. At 3 pi over 2, the sine, or the y-coordinate, is negative 1. And at 2 pi, we're back to 0. We've gone all the way around the circle. That's where that comes from. That's where these points come from. Right off the unit circle. So, the thing you have to think about is the amplitude, which you get from the equation. You have to determine the period when you're graphing sine functions. And finding the intervals might help you. We'll look at that tomorrow, or on the back side of this page. So that's sine graph. Cosine is very, very similar. Think about what you know already about cosine. So we know that, first of all, in this equation, the amplitude, again, is going to be 1. There's a 1 here and a 1 here. Okay? We also know that the cosine of 0 degrees is my x-coordinate, which is 1. That means that it starts right up here. The cosine of 0 degrees is at 1. The cosine at pi over 2 is 0. That's why it comes down here to 0. The cosine of pi is negative 1. That's why it's down here. And you can kind of see how it goes. So this here is the cosine graph. Let's talk about the period. I didn't really talk about the period for this graph. The period is going to be 2 pi divided by my b, which is right here, which is 1. So my period again here is 2 pi. And we can see that it goes from here to here, which is 2 pi. Period is 2 pi. So I've got my period. These are my intervals, which are actually also going to be, let's see, 2 pi divided by 4. My intervals here are pi over 2, again, which is true. Here's, if you cut this in fourths, you can see there's 4 intervals, and they're each pi over 2 long. And that kind of helps you graph it later. The amplitude here, you notice, is 1. And it's not always going to be 1. It's just going to be whatever the absolute value of A is. That's going to be your amplitude for your graph. So let's just kind of turn this over and practice some of this. All right, we'll look at tangent in a minute. So for here, we have to graph the sine of 3x. Okay, so number 1, I would say identify your amplitude. And we can see from this equation that A is actually 1. So my amplitude is 1. And I know it's a sine graph. Sine graph starts at 0. Okay, and my amplitude, I'm just going to make it spread out a little bit, so I'm going to say this is 1 and this is negative 1. Okay, so there's my amplitude, how high and how low my graph goes. All right, and then you mark that on the y-axis, just as long as you stay consistent. Number 2, determine the period. Now remember, on the other side, I said that you use this equation, 2 pi over b. In this function, my b is 3. So my period is going to be 2 pi over 3. Okay, now I'm kind of still not quite sure exactly how to work that, so let's just see what my intervals are. So let's just say I take my intervals. I know the last one is going to be 2 pi over 3, because that's how long my period is. But if I take 2 pi over 3 and divide it by 4, I'll find out what each of these have to be. So this is 4 over 1. I want to get rid of that denominator. So I'm actually going to do 2 pi over 3 times the reciprocal of 4, which is going to be, I know it's getting squinched, I'm sorry, which is going to be 2 pi over 12, which reduces to pi over 6. So my intervals are pi over 6. Okay, so I know the first thing is pi over 6. If I double pi over 6, multiply it by 2, I'm going to get 2 pi over 6, which is simply pi over 3. Okay. Then to get my third interval, I take this and multiply it by 3, which is 3 pi over 6, which reduces to pi over 2. Okay, so I'm going to start by marking my first thing here as pi over 6. And then my next one is pi over 3, pi over 2, and 2 pi over 3. And this helps me because I know in the sine graph I start at 0, and the first interval is pi over 6, so I put a dot up there. And then I go back down in the sine graph, and then I come back down up here, and then up here. So there's 4 intervals, and you can kind of mark your dots at those spots and connect them. And there you go. There's the graph of y equals sine 3 of x. The only problem is you have to remember that a sine graph keeps going. So you're going to just extend this a little bit on that one. And we're going to take this just a little bit further. And I know every spot that I did on this, it goes up here, and then it goes down, and then it goes down, and then it goes down. So my graph would actually kind of keep going in that pattern. And so that's how you do it. I know you might be kind of saying, what, right now? Let's just try another one here. So here we have y equals 3 cosine x. All right. So number 1, my amplitude is equal to 3. So we can mark that right now on our y-axis. Kind of looks like in this graph, each one is going to be 1. So there's a 3 and there's negative 3. There's my amplitude. Number 2, my period is going to be 2 pi over b. Here my b is 1. So my period is just 2 pi. Okay? And then I know I can, if I need to, you don't always have to do this, you can identify your intervals as 2 pi divided by 4, because there's 4 intervals in a sine and cosine graph, which means that they're each going to be pi over 2 intervals. So I'm going to start with pi over 2. I'm going to double that, and that becomes pi for my next one. And then 3 of these is 3 pi over 2. And 4 of them, I know I'm going to end in 2 pi. So I'm going to start here and label this part as pi over 2 and pi, 3 pi over 2, and 2 pi. Okay, now, I remember from the other side here that cosine graph always starts up high. Okay, so that means I'm going to start with my cosine graph up here. I'm going to go through my intervals that I created, knowing that I'm going to go down and up and up. So you kind of just do this. And it keeps going forever, so you put an arrow there. But you also have to go into the negative, because sine and cosine have negative x's in them. So it's going to be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And it's going to go down and down and up and up. So you just kind of do this. There you go, cosine graph. Let's do another cosine graph. Number 1, the amplitude is 3. Okay, so I'm going to go up 1, 2, 3, and negative 3. Number 2, the period is equal to 2 pi over b. Here my b is pi over 2, so I'm going to take it down here, and I'm going to write 2 pi over 2. When you have that fraction in the bottom, you get rid of it, and you multiply by its reciprocal, which is 2 over pi. And now here you can see that these cancel out, and my period will actually equal 4. So here, it's not in radians, it's just in numbers. So I'm going to number my x-axis up to 4. 1, 2, 3, 4. I don't even need to do intervals. Okay, I'm just going to go up by ones. 5, 6, 7, 8. I know at each interval, for cosine I start up high, I go here, then I go down to the bottom of my amplitude, and then up, and then up, and then down again, down, up, up. And then you connect them. There you go. So there's another. Okay, for tangent. This is what a tangent graph looks like. It's a little different than sine and cosine, and it goes forever. Okay? What you have to remember with tangent is that the period is equal to pi over b. A and B are still in the same spot with the tangent graph. Okay? All you need to do for this section right here is kind of think about where the asymptotes are going to be. Because you have to remember on this graph that there were some spots where tangent was undefined. Tangent at 0 degrees, remember, is y divided by x, which is 0. However, the tangent at 90 degrees is undefined. That means the line cannot cross that particular point there. Tangent at 180 degrees is 0. Tangent at 270 was undefined, or 3 pi over 2. So, kind of look at it like this. The tangent of 0 is 0. So right here, that's where that's at. Okay? The tangent of 90 degrees is undefined. Oh, wait a minute. I can't have a tangent there. Can't have a graph cross that point. Now remember, 90 degrees is pi over 2. So that's where the undefined is. Okay? Tangent of 180 equals 0. Remember, 180 is pi. And look, that's exactly where it hits the graph here, right here. That's 180 degrees. If I keep going, actually, if I think about going the other way, the tangent of negative 90 degrees is also going to be undefined. And that's where this comes from, negative pi over 2. So you have to mark all those spots where it's undefined with an asymptote, is what you're doing. And you got to remember here then, from here to here, from one asymptote to the other, is your period. So if I go back to the equation and figure that out, my period here actually would be pi divided by 1, which is pi. And with tangent, you have to spread that over in the positive x and the negative x. So pi is here. This is pi over 2 and this is pi over 2. It totals pi. And then you go to the next one. Another pi over. And then you have another period. And then you go another pi over and you have another period. You go another pi over here in the negative direction and you have another period. So that's kind of all you got to do for a tangent graph. Let's practice that. All right, 1 period of the function y equals 2 tangent 1/2 x. I don't know why it says 1 period up there. Let's just graph what it would look like. Okay, so number 1, there is no amplitude per se. Actually what it is it's really just a stretch when there's a number here. It's really just stretching the graph, if you remember what a stretch is. We could say, yeah, a is 2, but it's really just a stretch. All right, number 2, we have to determine the period that we're working with in this particular function. Now the period is pi over the absolute value of b. So here it's pi over 1/2. And to get rid of that fraction in the denominator, you just flip it and multiply. So you're actually going to get 2 pi. So you have to do pi on each side of the y-axis. That's just how tangent is set up. So I'm going to go over here to pi and over here to negative pi. And if I make my asymptotes there, it's going to give me a period of 2 pi. Okay? And then if I go over another 2 pi, there's going to be another asymptote. And if I go this direction, another 2 pi, it's going to be another asymptote. And then to draw your tangent graphs, it hits the x-axis exactly in the center of those asymptotes. And you just kind of go up and make sure your tangent lines don't cross over the asymptote. And it just goes like that forever. And you've got the tangent graph there. Okay, we're not going to do this one. So just to recap, for sine and cosine, you get the amplitude from the equation, and you get the period by doing this. And if you need some help figuring out your intervals, you can use that equation. Okay, and remember that the sine graph starts at 0, cosine graph starts up at 1 or whatever your amplitude is. And then for tangent, you can look at the amplitude, but it's really just how it's sort of stretched out. But you need to determine the period by taking pi and dividing it by the absolute value of b. So you have a period of 2 pi, and you split that up over the y-axis. Part of it goes in the positive and part of it goes in the negative. And then you just kind of put the x-intercepts there and draw it like that. And it's kind of fun to play with these on your calculator if you feel so inspired. So for the practice, I just want you to do the worksheet on the other side. All of it. It's not much. Number 10 is challenging. You can try it. All right, there you go.